So, welcome everyone to our next series of our preparation training for LPIC 303 security. Today we'll jump in another topic and actually we'll talk about access control. In particular today, we will focus on discretionary access control. Let us begin. Today probably we'll have a shorter session as usual as due to the topic. So what are we going to talk today about? On the one hand, we are going to talk about file ownership, permissions, including set UID and set group ID. Then we'll talk about a little bit on access control lists and what are the utilities that you can use to use access control list. And last but not least, also about extended attributes and attribute classes, where you usually use this either for setting capabilities on the Linux operating system, but they are also used by mandatory access control implementation, like for instance, SA Linux. So let us continue. A little background before we continue. So a little background about the Linux file system, as we are going to talk about access control and also on a file system level. It's good to recall just some very superficial background on how the Linux file system is set up. So we have on the picture above, we have our drive, which can be well, as a physical hard drive or a virtual hard drive, which we usually divide into different partitions. And in one of these partitions, we usually install a specific file system. And in Linux, usually a file system contains a boot block, a super block, and then you find the inodes, the inode list, which refer to the different data that you store on the file system, and then you have the directory blocks and the data blocks. So then you see below a different view on that, where we have the inode list, and you have the inodes which refer to the specific data block. In other words, where you find actually the data that is referred by this inode. The inodes themselves, so there is where we store the permissions for a specific file. And the inode themselves, especially in the mode section, we store the permissions for a specific file in the on the file system that is stored on the file system. As you see here, there are the user, the group, and others, which are what you usually see while using the operating system. You have the sticky bit, which you mostly encounter when in the temporary files. You have the set UID and the set group ID, which are bits that with which you are able and you are allowed to execute the file or the program. It's usually set for programs which are anyway stored as files, as in the Linux operating system, everything is a file, which allow you to execute that program not with the UID of the current user, but rather with the UID of the owner of that file. So meaning if there is a program which its ownership is set by the root user, allowing you to execute this program, it can be only done if that you put the SUID, for instance. This is not the most recommended way. So it's usually recommended to use capabilities and to let's say reduce the scope of the file, so not giving it the highest privilege permissions, Nevertheless, still this set UID and set group ID exists. So it's good for you to know and to make use of them in particular cases. And also the file type. So what type of file actually are we talking about? So um, from a different perspective here, so I have a table into going a little bit into more details what they mean. So the permission bits. So now we have, let's say, zooming in into the mode where we have the description bit. So we have 4 bits describing which what kind of file type we have. So we have, if we see a dash in our terminal, we know that this is just a regular file. If we see a D, we know that this is a directory. B stands for block devices, C for character devices, L for symbolic links, P for pipe, and S for sockets. So these are the symbols and that we see and understand what kind of file are we dealing with. On the other hand, so we have the set UID and the group ID and also the sticky bit which we see on in Hexa. Here, the 8 stands for the set UID, for the group UID and the sticky bit, and so on and so forth. So we have now that what everyone mostly sees in the when they're using the system, which is the ownership of the file. So we have write and read access. For example, we read in if this is directory, we list the files that are stored in the directory. Otherwise, we read the file. We write, if it is in a directory, we add and delete files, file names and links and so on and so forth. And the same is for the group. And if it's a X, we are able to execute. And if it's a directory, while we have the X permission, we are able to traverse the directory. So we are able to change and to go into the directory. And also we have the others, which are, well, anyone else in the system, not only the owner and not only those that are at the same group as the owner, but everyone in the system has permissions to a specific file. So let's talk a little bit about the discretionary access control now that we have some background. So what is some general information about the discretionary access control? So this is the basic access control for objects in a file system. So this is the basic access control that is implemented by default in your Linux operating system. It allows subjects, and with the subjects we mean active processes, which are users, and processor we mean active in a sense that they take actions and they perform and execute actions on objects, which are passive, like files, directories, and programs. This discretionary access control specifies the permissions. So access to object, it's based on user group and ownership. And access permissions to objects are specified when objects are created. So when you create an object, then the object, it just gets the permissions that are by default set. So it usually, you as an owner will get full permissions, access permissions on the file, meaning you have read, write, and execute permissions. You can kind of let's say, change the default permissions via using umask, and nevertheless, we'll see this, what it means. And subjects can pass permissions of objects to any other subject. So this is something from a security perspective that you need to see as critical, and to make you well, be a little bit skeptical, because this is a big issue from a security perspective. You as an owner, so it's an ownership permissions control rather than a system permissions control. So if you create a file and you write sensitive data on that file, and you share that file or the permissions to other users on the systems, or you set your permissions in a wrong way, you configured them wrongly, then everyone maybe is able to access that file or to execute the program, and also to maybe exploit any vulnerabilities on specific program and to escalate the privileges of this program. So that is why there are also more relevant and more secure access control, which are kind of system access control as the mandatory access control. About this, we'll talk in the next session, which might be at the end of this month or after the summer holidays. We haven't decided yet, but we will anyway inform you as soon as possible. What are some DAC utilities which you need to know about, especially for preparing for the exam? So it's change mode, which will change the permissions on a specific file. So you can change the permissions in meaning for reading, executing, or writing on the file. Change ownership, so you can change the owner and the group of the file. And those that we want to see, it's the access control list, which are more specific. So we have utilities as get the file access control list, set the file access control list, and also the set UID and set GID, which I was talking before, where you can change the mode so they execute a little bit, allowing to execute with the owner permissions the file. So maybe I'll just want to show a little bit of the utilities in here. So let me. I see this a little bit. Seems to me. So I hope now you can see a little bit better. That is better seen. So yeah, so let's see, like for example, set file access control list. So what you can do with that is you can modify, for example, saying -m, you can modify the current access control of the file. You can remove them and so on and so forth. So I wouldn't go very much into the detail of this one. Nevertheless, I would like just to show you this, that you can have the same even with the gets. You have the help, and if you need to learn a little bit more about this, and you need to use them in your daily life, it's always a good idea to look at the help of the manual pages and to learn a little bit more about these utilities. With the UMask, I was saying before the UMask. So if you go in the UMask, you will see that if you create a file, so you would have the opposite of it. If you have a tool, so let's create maybe a file. Let's call this root text, and let's insert hello. So now, if we see the food file, it's 544, right? So this is what this 0 to 2 actually does. It makes you get just the opposite of that. So you'll have, when you create a file, you would have write and read permissions, and you'll have for the group and for the other just read permissions. So by changing the UMask, you can change the default behavior of the file ownership when you create a file. If we try to get the ASL of the file, now that we created a new file, you will see, for example, a different view. So it have the file name, the owner group, the rights of the user, the rights of the group, and the rights of the owner. So you can have this. I mean, you can play a little bit around. Let me see. You can show this even in a tabular. So by T, yeah. So it's just for the sake of formatting. So you can have even different ways of showing those permissions. For example, well, you can change these permissions again. You can change this with, okay, so let's say we want to change, we want the group also to be able to write. So we'll say we have 6 here, and we also want the group to write, but we want the other people to not have access at all at this file. So you would just, and if we again in the file, you'll see that now you have a difference. So the others there cannot do anything about this file, and they don't see it at all. They cannot even read. And now the user and the group and everyone in the group where the user is able actually also to write on the file and not only to read the file. So this is you can change whatever and how you want, because as I said, this is your own file, and you are able to do and to whatever. So let me use this set so let us use this and to change this again. So we said, let me look at the help, because I usually, so we need to modify the file, and then what else we need to say? The permissions. So we need to say the user. So it's user. It's Ali, so we don't want to change this, and the permissions is just read, write, and execute. So we want to give this also an execute permissions. And so now if we get the file, oops. So now you see that we added again from the ACL a new user. So if we just look at this file right now, so you will see a plus here. Okay, so we had read write for the user, for the owner. Now you have a read, write, and execute for someone that is in the same group as we put this into the same. And this, at the end, you see a plus. If you have a plus in here, you will identify that this file is actually also handled by another permissions, not only the general, the default permissions, and these permissions are the security, the access control list permissions. So if we want to remove, this one, we have to say remove entries from of the file. So what did I say here? We want to remove external ones and remove entries from the files. Okay, so now I broke it myself. No, this is it. And I need to say Kali here. Yeah, so now I got it. So you see it, sometimes I just forget. And now this is gone. So if we again look at this, you'll see again the plus here, because this system where I'm working on is using the access control. This is an additional access control on the files. So this is about the discretionary access control utilities you need to learn. So what about the extended attributes? So extended attributes are actually name value pairs that are associated with and permanently with files and directories. So what you can do is well, extending to normal attributes that are associated with inodes. You can provide additional functionality to the file system, in particular, for example, additional security features. So you can extend that file with specific features. There are 4 classes which we use for extended attributes, which one is security, one is system, one is trusted, and the other one is user. And you can use one of these classes or so-called namespaces. So these are the names that you give to the file, and then the value you give to the file. So these are the classes and the value, and then you provide, so in which class you put this name, these pairs of name and value. And this is the basis for the mandatory access control. So if you look at the files in, well, if you look at this SA Linux, in principle, it does just use these extended attributes, and also Linux capabilities are based on this extended file attributes. So in the SA Linux, you will have this security group, which is used by SA Linux, and it annotates, so it extends all the files with putting name values like classes and security levels on the files, allowing a system to access those information and making system-centric decision rather than the decision being made by the owner of the file with respect to the permissions that you have on the file. And there are 2 utilities that you can use, so which is get file attributes and set file attributes. And we will also shortly play a little bit around with this one. So if we attributes and we say so we see that there isn't any file attributes, any extended file attributes on this file. So if we want to see, so okay, what we can do is, let me clean. So let us add a hash value to this file so that we can make sure that attribute, and if we say -n, so we want to put this on user, we say this is the checksum of the file and this is the value. So so the n, or the namespace, is, well, we put this in the user namespace. We give this attribute a name, which is, we call this the checksum, and we give it a value. So -v is for the value, and so this is the checksum that we have calculated before of the file. So if we enter and we try to get those again, you will find that there is a checksum in this one, right? So, and if you identify this, so we need to enter this for getting the value as well. So it's always a good idea to have a look at the help and see what are the options. So the dump, it's extend all the values, so it get the name extended attribute value. So we got only the name, and if you want the value, so you have to put the -d. So with that, now this file, it has this extended attribute also stored. So where does it make sense? So from a security perspective, so imagine now you have this extended attribute edit as a checksum for the file, and you want to make sure that this file has not been, let's say, modified in an unintentional way from any third party during using that file. So making sure that you have set your permissions right, anyway, so that at least no one being, let's say, people that have the permissions to change the file, but did they change this from the last time, right? So when it checked and we said, okay, so now this is the checksum of the file, did we change this from the last time? So by setting, for example, this hash value, you are able to well, to identify whether this file has been changed. Actually, its content has been changed from the last time. So this is what more or less the mandatory access control from SA Linux does. So by using these annotations, it just puts an annotation on the file, and with this annotation, the system, the central system can take a decision whether you are able to access the file or not access the file, even though you are the owner of the file. So the same principle can be done here to ensure the integrity of the file. So this is it for this session. As I said, so this session, it's a little bit short, as this is what we have got to understand and to learn for the discretionary access control. So these are the utilities that you needed to know. So the change of mode, ownership, group, setting your file access control list and getting them, and also using the extended attributes for the file. So I think it's not very very difficult, as long as you have kind of used those one time or sometimes, and you get so the concept behind it are not very difficult. So that's it from my side, and I want to ask if there are any questions so far with respect to what we have discussed today. Well, with that, I will conclude it for today. Thank you for your attention, and hope to see you in the next round, where we will talk about mandatory access control, and we'll go a little bit more into detail with respect to especially topics as SA Linux and AppArmor. So see you next time, and thank you for your attention. Bye-bye.